Dear students, in previous class we discussed about parabola, and today we will discuss about which are under comes elements of conic sections, that is ellipse. So elements of conic sections, chapter name is ellipse. So, objectives of the today's class: on completion of this period you would be able to define an ellipse, derive the standard equation of ellipse, find the relation connecting A, B, E. So let us see about ellipse. Identify the shape of the curve. See the diagram, and we can say this is in the shape of ellipse, like orbit, or we can say the planets moves, or in the planet like Earth, it revolves, or it rotates, or it moves around the sun in the way like eclipse or ellipse, or we can say oval shape. What is the eccentricity of this curve? We already discussed eccentricity of the parabola. The parabola's eccentricity is 1, and ellipse eccentricity is less than 1. So, definition: a conic section whose eccentricity is less than 1 is an ellipse. Eccentricity means we know SP by PM, that equals to E and is less than 1. Then SP equals to E into PM, and SP is nothing but distance between fixed point and moving point. S is a focus, and P is on the path, or on the diagram, or on the ellipse. So PM, distance between fixed line and moving point. So moving point is P, and fixed line we can say directrix. So from P to M, perpendicular distance from a point P to directrix at M, that is PM. To find that is not he, it is wrongly typed. To find the standard equation of ellipse. See here, sometimes in typing, or some words or some letters may missed, so you just omit it, or if you see the textbook you can know what are the words or what are the letters. You can easily notice the which is or which is wrong or which is correct. So here he is not the word suitable in this sentence, so you can know it it is not he, it is the, but by mistake it printed or it typed as he. So this type of mistakes you should find, and you should while note down you rectify and you write properly. Or if you have any confusion or any doubt, you can ask me, not only in this class PPTs, in previous class PPTs also. If any this type of printing mistake or typing or letter mistake or words mistake, I will tell you, and we can rectify and we can write or note down properly, so don't worry. And you can see the textbook also to know what is correct word or letter. So to find the standard equation of ellipse, see the diagram ellipse here. S and S1, 2 points are fixed points. The middle point is center, that is indicated with C, and here S and S dash both are fixed points, so both are focus points. So for focus is singular and plural is foci. So two focus points are called with the word foci. And see here, two fixed points, or we say two directrix, that is M1Z1 or MZ. MZ is right side and M1Z1 is left side. We can observe here SP. P is a point on the ellipse. The path is indicated in blue ink, and P is indicated in red ink. X comma Y is a point on the parabola, and we can see SP and S1P also, and P2M and P2M1 both are the perpendicular distance from P2 directrix. So two directrix, we can say directresses, and here vertex A1 and B1. Generally we say two vertex. Actually we have four, but mainly we discussed about major axis vertex. So here A dash or A1, B dash or B1 are called minor vertex, or the vertices, minor vertices are these vertices are on or cuts or the intersected points with minor axis, and A1 are vertices on major axis where it cuts the ellipse. So let P x comma y be a point on the ellipse, S be the fixed point, and we can call it the focus. K1 be the fixed line, the directrix, which is the right side of the center. Let us fix the center C at the origin. Here C is the origin point. Major axis AA1 along x-axis. So here the AA1, which is in red ink or in red color, the line indicated in red ink is a major axis. It is along x-axis. major axis is the line through the foci S and S1 and perpendicular to directresses. Here major axis is perpendicular to two directrix, or we say directresses, which are located to each side of the center. Let A1 equals to 2A. The distance from A to A1 is 2A. As C is the midpoint of A1, CA equals to CA1 equals to A, small a. So from center to vertex, the distance is A. So we have two vertices, one is left and one is right. So both are in the same distance, that is A. So the distance between two vertex is A plus A, 2A. Draw a line through S perpendicular to K1. Let it meet at Z. For right side directrix from P to P, draw a perpendicular line, then it meets at Z. Choose A and A1, 2 points on SZ, such that they divide SZ in the ratio E:1. Actually, it is less than 1 or E:1. Okay, let us see. That is SA by Z, AZ equals to E by 1. Actually, is less than 1. Then SA equal to E into AZ. Okay. Then and SA1 by A1 by Z equals to E. It is also eccentricity is also less than 1. Then SA1 equals to E into A1Z. Here ratio E:1 is taken, and E:1 means E by 1. And cross multiplication he did. We can directly take only E in the denominator. If there is no denominator, means we can consider it as a 1. That's why we have taken a E:1. So that is the reason. And 1 plus 2 gives SA plus SA dash equals to E into AZ plus A1Z. Here left side terms are added, and the same way right side terms are added. So SA, it is we can write as CS minus CA. SA means from the distance from focus to vertex, and CS is from center to focus, and CA means from center to vertex. So here SCA is we can say focus to vertex, but CS is center to focus, and CA is center to vertex. Yes, A dash, yes, focus, A dash is vertex which is left side. So C2S and C2A. C2S and C2A. So SA dash is the distance from focus to vertex. In SA dash, or SA1, okay. CS is center to focus and center to vertex. So here let us, from diagram we can understand this. SA plus SA dash means focus to vertex and the same time focus to another vertex. So focus to vertex is we can say CA minus CS, and focus to another vertex means focus to another vertex means CA plus CS. So CA is center to vertex. So okay, let us see the diagram and we can conclude easily. That is AZ plus A1Z, right side terms, AZ and A1Z, we can say AA1, and CS is 2CS. So 2CS means center to focus equals to 2AE. AA1 is already we know 2A. Then CS equals to A, 2 get cancelled, so CS equals to A. In the left side, CS minus CA plus CS plus CA. In CA, positive and negative will be cancelled. So these four terms are written from diagram if you observe. Next, therefore, yes, focus is A comma 0 and another focus is minus A comma 0. So based on diagram we can conclude this. S is A comma 0 and S1 minus A comma 0. Next, 2 minus 1 gives SA1 minus SA equals to E into A1Z minus AZ. Then AA1 equals to E into CZ plus CA1 minus of CA minus CZ. So 2A equal to E into 2 into CZ. You multiply with minus in the right side terms which are in bracket, then it is positive CZ plus CZ 2CZ, CA1 minus CA will get cancelled because distance is same. Next, Cz equals to A by E. So from the definition of the ellipse we have Sp by Pm equals to E, and Sp equals to E into Pm, E into Nz, that is E into Cz minus Cn, that is E into A by E minus X. Sp square equals to E square into Pm square, and Sp is distance from focus to point P, that is x minus ae whole square plus y minus 0 whole square equals to e square into a by e minus x whole square. On simplification we get x square of 1 minus e square plus y square equals to a square into 1 minus e square. Dividing with a square into 1 minus e square, we get x square by a square plus y square by b square equals to 1. See, this is the standard equation and this is the process how we will get. So the process is may not very important. If you understand, okay, otherwise you think it is based on eccentricity. We are got the standard equation after simplification. In the process of simplification we got standard equation. So is there any, if you are a doubt you can ask me, I will clear your doubt, because here we are written direct steps based on diagram. We wrote some 1-2 steps are written directly or taken directly, but the logic is based on eccentricity and diagram. So finally we got, or we are extracted, or we are simplified. Standard equation of the ellipse is here the background is white shaded given, that is x square by a square plus y square by b square equals to 1. X square by a square plus y square by b square equals to 1 represents the equation of the ellipse, where b square equals to a square into 1 minus a square, and b square by a square equals to 1 minus a square. That implies e square equals to 1 minus b square by a square. So if we bring the right side minus e square term to the left, it will become positive, and left side b square by a square, if we bring right side, it will be negative. So e square equals to, we can say, 1 minus b square by a square. That equals to a square minus b square by a square by LCM. Then left side we have e square. The power, if it goes to right side, it is becomes under root or square. So e equals to under root of a square minus b square by a square. So this is the eccentricity for ellipse. The center at 0, 0, length of major axis is 2a, length of minor axis is 2b. Why we are saying minor? Because in the diagram horizontally it is extracted, and vertically it is a small axis. That's why we are saying minor axis. horizontal it is showing a big, and at vertical it is a little. So that's why we say it is a minor axis and its length is 2b. 4c, at s is ae comma 0 and s1 is minus ae comma 0. To center we have both vertices, both focuses also. Okay, vertices and focus. So two focus points we say 4c. One is the distance at ae comma 0 from origin, another is minus ae comma 0. So between the focus points, we have the midpoint, that is a center here 0 comma 0. Vertices at a is a comma 0 and a1 is minus a comma 0. So here vertices also same distance from center, and same distance from focus of each side focus point. So here midpoint of vertices is origin or center. Equation of directresses are, we have two directrix both sides of the center. So one is x equals to a by e and another one is x equals to minus a by e. So two fixed lines, we named it directrix. Plural word is directresses. So each one is located at x equals to a by e and x equals to minus a by e, and these two directresses midpoint is center. So focus midpoint is center, that is 4c midpoint is center, vertices midpoint is also center, and directresses midpoint is also center. Similarly, equation of the ellipse with center C at the origin and major axis along y-axis is, see the diagram is here changed. Along y-axis means the oval shape is like vertical. In first, on the ellipse diagram is like a egg in the horizontal form. Now it is in the vertical form if major axis is along y-axis. See, equation is same, x square by a square plus y square by b square equals to 1. But the diagram and its some parts will be little bit changed. Equation of the ellipse whose major axis is on y-axis is x square by a square plus y square by b square equals to 1. Here a is the distance from center to vertex which on y-axis. So that's why it is written, the equation is y square by a square. In previous also you must remember it is along y-axis. If the major axis is there, then the equation is little bit changed. First I read x square, but it is not x square. It is, you will look y square by a square plus x square by b square equals to 1. That means we are giving the preference to y, so that's why, because y is major axis, so first we wrote y square by a square. So to look, it is a first equation, but in the first equation, in the numerator x square, but here in the first term the numerator is y square, so that is the little difference. That means in place of x y came, and in place of y x came, because the axes are changed. So equation is changed. On x y taken, on y x took. So this is the small difference. So look, first form is x square by a square plus y square by b square equals to 1, along with major axis, its axis. Now here major axis is along with y axis, so the equation is y square by a square plus x square by b square equals to 1. This is the difference we must notice. So equation of the ellipse whose major axis is on y axis is y square by a square plus x square by b square equals to 1, where b square equals to a square into 1 minus e square. Center at C 0, 0. Length of major axis equals to 2a. Length of minor axis equals to 2b. See, center is same, and major axis 2a, minor axis 2b, and foci is 0, a, because it is on y axis. X values are 0, abscissas are 0. That's why here foci is s 0, ae, and s1 is 0, minus ae. Distance between foci s1 equals to 2 into ae. The same, but it is along with y axis. The first form also same formulas for the parts, and here also same, only change in focus. The first form ae, 0, in the second form 0, ae. That is the difference, and remaining same. Distance between directresses. z1 equals to 2 into a by e. The distance between directresses is same. In the first form also we have 2 into a by e, and in the second form also we have 2 into a by e. Distance between vertices, this is also same. a1 equals to 2a. Vertices, these are little changed. In the first form a, 0, but here in the second form vertices is 0, a, and another vertex a1 is 0, minus a, because these are on y axis. On the y axis x values are 0, and the length of the distance we are taken a, in opposite direction minus a. In both the forms we taken the letters same, only difference is axis. That's why focus and vertices are only changed. remaining parts and remaining lengths are as it is. Equation of directresses are y equals to a by e and y equals to minus a by e. Here we are see the difference from first form and second form of the directresses. In the first form, x equals to a by e because they are on x-axis. In the second form, they are on y-axis, so y equals to a by e. That is the main difference. So focus is changed and directrix changed and directrix not, vertices changed and equation of directrix are changed. Changed means the first form to second form, the axis changed. So here directrix x equals to a by e is changed with y equals to a by e. So in place of x we given y. In vertices we given preference to ordinates. In focus we given the preference to ordinates. So here the preference is given to y-axis because it is a second form and its axis is along with the y-axis. Y-axis is the major axis. So equation is also in place of x we taken y, in place of y we taken x. The lengths are same as it is in the first form, so that's why remaining parts are same. Let us see quiz, some questions. First one, what type of the cross section of a cone is an ellipse? Horizontal, options are given like horizontal, vertical, inclined. So horizontal is not, because if we cut the horizontal cone, so its shape is a circle but not a ellipse. If we cut a vertical to a cone, so it is not in the form of ellipse because it is in the form of a hyperbola, that is open curve. It is discussed, it will be discussed in earlier classes, or after ellipse we discuss about hyperbola. So inclined means a certain slope between the horizontal and vertical, that inclined, like this. When we calculate numerator and denominator like cross, like in that way, that is that cross line little bit bent, not a horizontal, not a vertical, in between 0 to 90. If you cuts it like this, inclined with little bit angle, that is 30 degrees or 45, 60, like that. If you cut that cone, and after that if you see the shape of that cone, it is look like a ellipse or a oval shape. So inclined is the answer. Next, eccentricity of an ellipse is, see, the parabola eccentricity is 1. When come to the ellipse, its eccentricity is less than 1 always, and any ellipse SP by PM is less than 1. If it is 1, it is not ellipse, it is called a parabola. If the eccentricity is greater than 1, then it is said to or called a hyperbola. So eccentricity of an ellipse is, options are given: A equal to 1, and B is less than 1, and C is greater than 1. So answer is, option is B, is less than 1. And summary. In this session, you have learned for an ellipse, first form or standard form is x square by a square plus y square by b square equals to 1. Here the axis is along with x-axis. That means major axis is along with x-axis. Length of major axis is 2a, or 2 into a. A is the distance from center to vertex. Length of minor axis is equals to 2b. So b is the distance from center to vertex at minor in positive side. The distance is plus b, and in negative side same distance. So the distance is b plus b, 2b. So on minor axis we have two vertices because it cuts at two places, because ellipse is a closed curve. And major axis also cuts at two places and two vertices framed. So length of major axis is 2a and length of minor axis is 2b. Eccentricity E equals to under root of a square minus b square by a square. Distance between foci S1 equals to 2 into a into e, or 2 into a, or 2ae. This is very important, we have to remember. Distance between foci is 2ae. From center to focus is distance is a. So we have two focus, each one is opposite side or either side to the center point with same distance, that is AE. So AE plus AE, 2AE. Distance between directresses ZZ1 equals to 2 into A by E. So one directrix is located from center is A by E distance. So another also same from center. So A by E, 2 into A by E, or 2A by E is said as a distance between directresses. Distance between vertices A1 equals to 2A. This is about ellipse, and we already discussed at the beginning. Mainly 3 parts are called conic sections. One is parabola, and ellipse, and final one is, and third one is hyperbola. These are called mainly conic sections, and in this, based on eccentricity, we can take it as a condition. If eccentricity is 1, we say it is a parabola. If eccentricity is less than 1, we say ellipse. If it is greater than 1, then we say hyperbola. So first you have to see the diagram or picture of the ellipse, then you can understand where the vertices are there and where foci are there, where directrix are there, what is major axis, why it is called major axis, and what is minor axis, why it is called minor axis, and what is the center, where it is the center, and what is the relation, how they are formed, how the distance from center to focus, and vertices and directrices. So this is about ellipse, and you try to see the different forms in textbook and understand each and every parts of the ellipse, and try to do the problems which are given in exercise. And if you have any doubts, you can call me or ask me. You can post your doubt on WhatsApp also, so that you can do easily and without doubt. And see the example problems. Based on example problems, you can do exercise problems. So first understand how the solutions are given at examples. Then you can easily know how to do the exercise problems. So try, and remaining we discussed about in next class. We will discuss in next class. Thank you.